Hello everyone, welcome to my channel. In today's video, we'll create a deep neural network on Fashion MNIST dataset, which can be used as a college assignment or to just start a journey of deep neural network. So here I have started my notebook by using that command, and I will open my project folder. So this is my projects file. So I have divided that problem into different steps. So first of all, the first process will be to import the libraries. We have of course, when we are using Jupyter Notebook, we are required to have Python installed in your system as well as Jupyter Notebook. You also have to install other libraries such as NumPy, Matplotlib, Pandas, OpenCV, and all. So these are the libraries we have to install, and also we have to install TensorFlow, the latest version of TensorFlow. So these are the important libraries we're gonna use in this project: TensorFlow STF, and we in the TensorFlow there is Keras integrated in that, and there is a Fashion MNIST dataset. There is also MNIST dataset. I have also created a video on simple MNIST dataset, which is a digits dataset. It is used to classify digits from 0 to 9. If you want to see that video, I will give the link in the description. And then we have to also import some utils, including two categoricals and some models: deep neural network model, sequential, and we also have to use some neural network layers: dense layer, flatten layer, dropout layers. And why we have imported all those layers, I will discuss. So as running those cells might take time, that's why, to avoid that delay, I will just show you the output, because output is already included in that notebook. This before making that video, I just cross checked whether it is working or not, but it was working good. So we just, to save the time, we can just skip running those cells, or I can run as well. All right, so next step is to import a data set. To import that data set, we have to write fashion mnist.load dataset method, and there are two arrays, and each array has two different array, one for training. So initially there are two arrays: training and testing. And in training there are train images and their labels, so you can say input and their output. So as we all know that in machine learning, or we can say in neural network, what we in the training process, we give some input, and we teach, just like a child, we treat machine learning model as a child. First we will put like 50 images to our model. We're gonna show 50 images, let's say 50 images to our model, and we will teach that model, see, this is a t-shirt. For example, we will feed 50 t-shirts images, and we will teach that model that, see, this is a t-shirt. So labels are those like labels of the image, where what object it is. So we're gonna feed the image of t-shirt and label of t-shirt, and then in the testing we will test whether our model has learned so far or not. So it depends on different factors, like number of epochs, how much data is fed into the model. In this series, I'll also work on another data set, including like face mask detection. I have also created a video on cat and dog classification. If you want to see that video, I'll also include the link in the description. All right, so next one is data processing. Then we have to process our data. So we will check the shape, like how many number of rows and columns are there. So there are 60 in the training array. We have 60,000 samples. You can say 60,000 60,000 different images, and each image is 28 by 28. So image height is 28 pixels and width is 28 pixels. So in each image, if you see that, I will show you the array train images. So that is the array. Let's say 0. So you can see there are values of 0. So these are the pixel values. Let's say 0 for black color and 255 for white color, and any value between 0 to 255 will be gray or somewhere between gray. So the minimum pixel value is 0 for black color, and maximum pixel value is 255 for white color. And if they are colored images, there would be 3 channels for RGB, primary colors, red, green and blue. So for the colored images, I will discuss in the next video, which is on it's also the cat dog classification. Sorry, I've already discussed all that video. It's already on my channel. All right, then train images. We will reshape that folder image. So in order to put in the neural network, we here will work on 3-dimensional data. So there are just 28 by 28, so height and width. We also need channel, like we also gonna tell that model whether it is a colored image or three, like colored image or black and white image. For black and white, we will use here 1, and if it's color images, then we have to write here 3 for different 3 channels, red, green and blue. All right, so we have to just reshape that image. Train image dot shape of 0, like the number to train images dot shape is that entire array, and on 0 index there is 60,000. So what we are doing here is we are reshaping, we are resizing, you can say reshaping those 60,000 images as a whole into 28 by 28 by 1, and we are doing float value to 32, and we are dividing that value to the maximum, which is 255, to reduce the calculation time. So now each value will be pre-processed to you can say rescaling. Here we have done rescaling. Now the value would be between 0 to 1, as we have divided that to 255. All right, and that is train label dot to categorical. If we print here labels train labels, so these are like that. Okay, and then this is before and after that this is after. Okay, I will just train labels. Yeah, so here you can see the difference. For initially, okay, now the data is if you see the minimum and maximum value over here, it will be between 0 to 255. You can try it out by printing minimum and maximum value, and then you can see the categorical. As the neural network, if we talk about neural network, in output layer there would be, for that particular data set, there are 10 different classes. Let's assume it is a digit data 0 to 9. So there are 10 output classes. Okay, I will make it simple. Let's say your model is for cat and dog classification. So the output let's say that this is your hidden layer and this is your output layer. In the output layer, let's say for example, it work like that. So there can be number of hidden layers and after that it will tell you the probability of each class. For example, this is for cat and this is for dog, and we have put an image of cat and it will return, let's say this one is 0.96 and this one 0.04. So and we have passed the cat image here. How it work in the output layer, there will be two, for if there are two different classes in the output layer, there will be two nodes. Similarly, if there are 10 classes, then on the output layer there would be 10 nodes here. And similarly the label should be exactly like that. If let's say this is okay, how I can teach this? Okay, let's say 1, 2, 5, 6, 7, 8, 9, 10. So these are, for example, that particular problem, there are 10 nodes in the output layer, but the array size should be same. If you see over, if you see carefully in the first one, I will create a, okay, I will say it is first sample value is, first label's value is 9. So if you see here, all the values 0 to 8 will be 0, and that will the last one, ninth, will be 1. So it is according to the, that's what categorical do. Okay, if I show you here in notepad how it works in simple words, I will show you how it works. So let's say you have to represent 9. I will show 1, 2, 3, 4, 5. Like, let's say we have 5 classes. Okay, and our sample is, 5. How we will represent that 5? What we gonna do is, let's say, so our array value will be 0, 0, 0, 0, 0, and 1 for 5. All right, and for let's say sample is 2, output label is 2, what will be the array value? 0, 0, 1, 0, 0, 0. For let's say sample is sample belongs to class 3, then what would be the array value? 0, 0, 0, 1, 0, 0. For example, sample belongs to class 2, then what will be the value? 0, 0, 1, 0, 0, 0. So that's how categorical works. So this 0, this all, it all array will feed it into that nodes. The sample belongs to, for example, the sample belongs to, that one is for 0, that one is for 1, that one is for 2, and that one is for 3, that is for 4, that is for 5, that is for 6, 7, 8, and 9, and so on. For example, sample belongs to um, class 3, then only this node will be activate, other nodes will remain deactivate. Similarly, if sample belongs to class 2, this node will be activated and all other nodes will be deactivated. Similarly, if there are cat and dog classification, if sample belongs to class C, then this node will be activated and other output node will be deactivated. So that's how neural network works. So in the output layer there will be all probabilities, all classes, like all supposed classes. So only the predicted class node will be activated. So that's what it did. So you don't have to worry about, if you, in case you did not understand what was going through, so you can simply just skip that, the whole calculation. Two categorical function will do it for you. Okay, if I see, first belongs to first label, train images before train label and after train label. Okay, first sample belongs to class 0. If you see train label of first class, train label of 0, it say, okay, it should be train labels. See, all the values are zeros. Sirf on 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Only ninth location is 1. Similarly, the second sample belongs to 0 class. If you see here, only 0 location will be 1 and all other will be deactivated, 0. Similarly, the last sample, if we see here, let's say last sample's value, what is this, and if I see the last sample is 5. If you see 5 location, 0, 1, 2, 3, 4, 5, 5 is 1, rest all are 0. So that's how two categorical function work. So why we did that, this was the requirement of the our model. The label should have in categorical form, the array size should have equal to the number of classes. If you want to get the class of that, then you can use argmax function on that. So this is, it returned the value. Similarly, for 0 it will return 9, and for 1 it will return 0, and so on. So that's how it works. I hope you understand that. Okay, the next one you can see over here, we changed the shape. It was 60,000, 28, 28, 1, and the train labels initially, the test train labels was, if you check here, it here it was train labels was 60,000, just one dimensional, like the it is 1, 2, 3, 4, like in that number. Now it is two dimensional array, 60,000 by 10 for each class, like each index for each class. There are 10 classes, that's why this is 60,000 by 10. If we see the shape of first one, train images dot shape and train test label. So train, in the training there are 60,000 sample, and for testing there are 10,000 sample, and the width of the training and testing should have same, like its training images are also 28 by 28 by 1, and testing images are also 28 by 28 by 1, and similarly train labels are 60,000 by 10 and test labels are 10,000 by 10. In simple word, number of rows should be same. Sorry, my bad. Number of columns should be same. Number of rows can be, like for training there would be more samples, and for testing there would be less samples. If you see minimum and maximum value, as I discussed earlier, initially the minimum and maximum values was 0, 2, 2, 5, 5, representing the color. But as we divided it by 255, now it is 0 and 1. If I'm going into too detail, just I am just trying to make sure that you understand the logic behind this, but this you can implement that whole, this is very easy one. I will provide you the GitHub link so that you can just try implementing it. Train labels are that you can see the now the values are in 0 and 1, and it's in float. That's why there is dot after that. Okay, as we can see our numerical and categorical form, we can map those to string labels. Okay, now how I can came across that, when I searched official MNIST dataset, Fashion MNIST dataset, then I came across those label dictionary, because neural network work on numerical data, but we want our label in human readable format. Like also we can, as a human, we can read numeric values as well, but for easiness, I just want those into like the string value. So that's why I mapped each class. 0 is for t-shirts, 1 is for trouser, 2 is for pullovers. I get that array from official website of MNIST. All right, as we above have 60,000 images for training and 10,000 for testing. Okay, let's check, let's see, let's try to print or show an image. As I showed you earlier, with the argmax we can check the label. Actual label is 9, and if you see this label 9, it say 9, we don't know what is 9, so it make no sense for us. Similarly, if you say here 1 and train images of 1, so it say it's 0, so 0 make no sense for us. It's not, it not look like digit 0. So what we need here is, we need actual labels. So I will use the mapped label of class 1. So as you can see here, it says it is train labels of 1. So it says a trouser. Okay, if we see lab of 2, it's of 2, and this 2, it's it's a top. Actual label 0, so t-shirt, it is a t-shirt. So now we will train our model. I for the just training purpose or just teaching purpose, I just created a very simple and basic model. You can try adding more layers, and you can try changing the parameters. So our input shape is 28 by 28 by 1, and on first layer and first hidden layer, I need activation function value, and I will, to avoid overfitting problem, I will drop out 0.5, like 50% connections, and then on the second layer I use 64 nodes and activation function value, and then on the, I have just created 2 hidden layers, one input layer, very basic model, one input layer, 2 hidden layers, and 1 output layer. And you can just play around your values, you can try adding more layers, try adding more parameters, it's completely up to you. And then we will see the summary of that model. So as our input shape is 28 by 28 by 1, so by flattening those value, 28 into 28 value would be 784, and in the dense layer there are 128 nodes, so the parameter would be 22784. It works as a linear equation, line equation. So if you into 784 into 128 plus 128, value will be this one. So let's try it out. Let's say this is input, and this is, let's say, mx plus c. So this is our slope and plus intercept. We will consider the 128 for that. All right, 784 into 128 plus 128. So value will be this one. Similarly, how this value is calculated? 128 into 128 plus, okay, all right. At the dropout layer, the dropout layer, there will be no learnable parameters, so that's why it just says 0. And then for dense layer, how it is 8256, 128 into 64 plus 64, 128 into 64 plus 64. So this is 128 into 64 plus 64. Oh, okay. It's just my bad. I plus on 8192 plus 4. It should have 8912 plus 64. 8. Okay, let's try it again. 128 into 64 plus 64. So now value will be 8256. Similarly, 640 into 10 is 640 plus 10 is 650. So that's how this parameter calculator total learnable parameters. There is one trainable parameter. So we have to train all the layers. If it's transfer learning or we are using a pre-trained model, then we don't have to train all the parameters. That's why there are these two different one, trainable parameter and non-trainable parameter. So okay, now let's discuss further. We will discuss that transfer learning and predefined model later. Now later videos. Now we have to compile the model. I used optimizer Adam and categorical cross entropy, and matrix I would be accuracy. Optimizer, like what are those parameters in the training process? Model do feed forward and back propagation. If you want to learn more about the math behind feed forward and back propagation, you can comment on that video. I can make a separate video on that one, but for now, what it does, like in the training process, after every epoch there the weights and biases are changed. So optimizer, like how those weights and biases should be changed, who decide that, what decide that? The optimizer. And then the loss function during those epochs, what matrix is used? Loss, categorical cross entropy. According to that, the weights and biases are updated in each epoch. The matrix and the accuracy score tells us the proportion of actual labels and the total like right prediction divided by total number of samples. Alright, so now we have to train and test the model. I feed the training data to the model, batch size. So in each epoch, a batch size is like the parameter, how many sample you want to feed in one epoch in the training process. So history, I created that variable to save the output outcome of each epoch, so that I can create a graph, so that I can check the performance of that model in each epoch, during each epoch. Though we can see it over here as well, but it will help us to visualization is more easier to observe. Like we can make conclusion by using visualization easier. So you can see in the first epoch loss is 0.9 and accuracy is 0.6, and the second epoch loss decreased and accuracy increased. So what is that? The loss function decide that loss. Like it's basically, you can consider that in the first epoch the 60% predictions was correct, and 0.6% predictions were correct, and in the second 0.7 in the second one, the sorry, I will just put again in words. The accuracy is in the first during the first epoch there was 60% samples correct, and in the second epoch 70%, and third epoch 81%, and so on. So it will depend. There are some, like, you can pass any number of epoch. With each epoch as you can see over here, for that particular data set and for those parameters, after every epoch the performance of that model is increasing. Like you can see loss is decreasing from initially it was 9, and after uh, 12 epochs it decreased to 4, and accuracy initially it was 0.7 and now it increased to 8. Loss decreased to 4 and accuracy increased. So the number of it is not mandatory that with the like let's say you will say um we will make like 1000 number of epoch, we will give 1000 number of epochs. So it is not mandatory that the model will return 100% accuracy. So after some time, let's say after 50 epoch, the accuracy may started decreasing. This problem is called vanishing gradient problem. We can this concept is different one. So as I am trying to make this video simple, I will not go into that detail. So in simple word, we just have to check the right balance between those parameter. This is called parameter tuning. How many number of epochs you want and how much the batch size should be, how much would be the dropout rate. So we have to uh, do hit and trial method. There are some other parameters as well, though, called early stopping. With the early stopping, we can get the optimized number of epoch. Let's say after for example after 8th epoch the result is almost same, so it will stop that training process. That's what early processing do. Although our training process is completed, now our accuracy is 85% after 15th epoch. Now we will check the loss. We trained our data on training data. Sorry, we trained our model on training data, training samples, and the testing data is untouched for that model. We will like the training, we already feed a training data, so it is pretty obvious that it will return good result on the training data as it already recognized pattern of that particular data. Now but we want to check whether our model will perform good in practical scenarios or not. So that's why what we're gonna do is we will check it on testing data. So these are the testing images and testing label. We will see how it performed. So the loss is 0.36 and the accuracy is 8.87, which is pretty good. You may also have doubt that how it is possible. In the training accuracy was 80.85, but in the testing accuracy is 87. It also depends on the number of samples. In the training there are 60,000 samples and in the testing there are just 10,000 samples. So obviously if obviously the accuracy will affect according to the number of sample. It like in the training there are 60,000 sample and the testing there are 10,000 samples. Excess loss, and okay, let's now plot those values. So as I mentioned earlier, visualization makes it easier to conclude a result. Initially, that is the number of epochs 0 to 15. The loss decreased significantly and accuracy increased significantly with each epoch. As you can see, after like 3 epoch, there was a sharp, you can say sharp dip, sharp decrease in that. But after that the graph trend has changed, has it? So that's what we have concluded about it. Now let's make the prediction on our testing data, and then from the testing label you can see I predicted test images 0, like first sample. The prediction class is, it predicted that it belongs to class 9, and by checking label we can see that it is class 9 sample. Argument again. Okay, let's make prediction on another sample. 1. So our model says that sample belongs to class 2. Let's say whether it is actually belongs to class 2 or not. Okay. Yeah, our model is working good. Okay, let's say any other random sample from 10. Our model says that it belongs to class 4 and yeah, it belongs to class 4. Though the we have checked 3 samples, it is returning accurate result. As our model accuracy is 85%, not 100%. So we should not assume that our model would be correct every time. So there is also room for 15% error. So we have to keep that thing in mind as well, especially when we are doing on serious data, something like medical data set. So we have to be very particular according to, like, we should check the accuracy. We should work on accuracy. Okay, let's see. I have made prediction on the whole test data set, prediction on all the images. Initially I was doing just for first one, like I predicted though on whole, I made prediction on whole data set, but I was showing just one sample. Now we will just try figuring out each and every sample. Now I used subplot, matplotlib subplot to visualize that. I will upload that code to GitHub and I will give you the GitHub link in description. So you can see over here our model predicted correctly. So it is predicting ankle boot, pullover, trouser, this is shirt, this is trouser, this is a coat, this is a t-shirt. However, this data set is not like 28 by 28, which is not a good aspect ratio. So that's why these images are like blurry. So this is only just for teaching purposes. In a in a real-time application, data can have more complex, like data can have maybe 700 by 700, but also the training process will take longer as the because of image sizes. All right, so as we can see in that output, our model predicted correctly. So that's all for this video. Please do like, share and subscribe, and also please support me, guys. All right. Um, do like, share, and subscribe my channel. Thank you so much.